Audio Jungle. Audio Jungle.
So this is the first question based on CD nozzle. Okay. So this is like types of the similar kind of gate question. But here many value will calculate, but in gate exam they will ask only one or two value maximum. But here we are going to calculate more values. So don't bother about it. Okay, so much lengthy question. How they can ask? No, they can ask. But the thing is, they will ask only one or two value. Okay. And now, so listen. This is air. Please write this question. Air from a reservoir. Air from a reservoir at 10 atm and 80 degrees Celsius is discharged through a CD nozzle fitted to the reservoir. Fitted to the reservoir. Okay. The thrust exerted by jet issuing from the nozzle is 11.12 kilonewton. Okay. If the back pressure is 1 atm, calculate okay, calculate nozzle area, throat area, okay, throat areas, okay, and the Mach number of the jet issuing from the nozzle, and Mach number ME, you can say issuing from the nozzle means ME. Okay, assuming, this is the assumption, assuming flow through the nozzle is isentropic and correctly expanded. This type of technical word will come. So already I have told you what is the under expansion, over expansion. Okay, correctly expanded they have given to you, right? This is the question. Now we'll mark all the important value here. See what they have given to us. We'll mark all the important values here. It is nothing but reservoir they have given. So they have given reservoir. So all the value here, it is total value. If I say This is 10 atm, so it is pressure which is nothing but 10 atm. I told you reservoir means the velocity or flow of the fluid assumed to be zero, hence all the quantity inside the reservoir will be given. It will be given total quantity. So temperature will be P naught, which is nothing but 80 degrees Celsius, but convert into Kelvin. So you may get how much it is, 353 Kelvin. One thing clear, okay? And this CD nozzle is what fitted to the reservoir, okay? The thrust exerted by the jet engine also they have given from the nozzle is 11.12 kilonewton. This is also very important. And the back pressure they have given 1 atm. Okay, you have to calculate nozzle area, throat area, and ME, which is the exit Mach number of the flow of the fluid. Okay, or you can say air or gas. They have said the flow is what inside the nozzle isentropic, means they have clearly mentioned, or it is cleared now, there is no shock formation because inside the nozzle flow is isentropic. And one very special word they have given, correctly expanded. Okay, so how many types of the expansion I have told you? Expansion in nozzle. Okay. Because this word you should very clear about it. Okay, one was under expansion, over expansion, and third is fully expansion. Okay, fully expansion, or it is also called correctly expanded. Okay, or correct expansion. So what was the under expansion? Under expansion means still pressure is available to expand. So that means whatever the exit pressure, it is under expansion. Okay, exit pressure is greater than back pressure. Over expansion means the extra pressure is what extra expansion was there. Expansion means reduction in pressure, so extra reduction in pressure compared to the back pressure or atmospheric pressure, hence PE is less than PB. Okay, over expansion means extra expansion, you can say, or extra pressure drop, called over expansion. Under expansion means it is yet to expand, so means pressure is available now, extra pressure you can say available. Okay, and correctly or fully expanded means PE is equal to PB. So question, numerical question they are asking. Okay, many numerical question based on this they are asking. They will use the word fully expansion or correctly expansion, so that means P is equal to PB. This both are theoretical question here. Okay, you are not able to solve question based on this, but theory question they will ask to you, theory, and this is the numerical point of view. Okay, numerical point of view, this is very important. All right, so we'll write all the given data first. What are the given data? P naught, please write all the value here. P naught 10 atm, P naught is 353 Kelvin. Okay, and for fully expansion, PE is equal to PB, and back pressure also they have given to you how much? It is 1 atm. Back pressure check. It is 1 atm. These are the given data. Okay, from with this given data, what you can calculate? P naught you have and Pe you have. P naught by Pe you have. Okay, what you can calculate from P naught by Pe? Anything else they have given to you? That is okay. What is the P naught by P? Because it is isentropic, you can apply this formula: 1 plus gamma minus 1 by 2 me square to whole power gamma upon gamma minus 1, right? 2.15. So what is the exit Mach number from this formulation? If you do, then exit Mach number will be 2.15. This is what supersonic. Okay, so now we can draw one CD nozzle as per given problem. This is connected with the reservoir. Okay, P naught they have given to us, and here at the exit of nozzle, Mach is Me, which is nothing but 2.15. So obviously here Mach less than 1, here M greater than 1, and exit is 2.5. Right? This area will be exit area AE, and this will be, obviously it is M less than 1, here M greater than 1, so this will be what? M is equal to 1, which is nothing but A star. And if somebody will ask you, it is choked flow or not? Yes, it is choked flow. Choked flow means what? Once Mach number reach to sonic flow at the throat, then you can say it is choked flow. Okay, so whatever the mass flow rate you will calculate here for the choked flow, always it is maximum mass flow rate. Okay, I think Mach is was 2.15. No? Let me check. Mach is 2.15. Sorry, just correct it. Okay. So fine, this is the actually real problem, you can say. CD nozzle exit Mach number you achieve 2.15. Now what you have to calculate? You have to calculate the throat area, and what you have to calculate? Exit area. How you can calculate it? It's very simple. Now because you have this value of what it is called exit Mach number, so with the help of this you can calculate. Now what how you can calculate this? Simple, that area velocity rule. No? Area Mach number, sorry, area Mach number rule or area Mach number relation, you know very well. So area Mach number relation, area Mach relation. What is the area Mach relation? I told you it is A by A star. What was the formula? 1 by M, 2 upon gamma plus 1. Yes or no? 2 upon gamma plus 1 in bracket. It was 1 plus gamma minus 1 by 2 M square, okay, to whole power this is the value. Okay, now you are going to write this as a exit Mach number. I told you the technique. So exit Mach number divided by A star will be what? 1 upon, why you are writing A exit by A star? Because M exit you know, na? M exit just now you have calculated 2.15, so you can use A exit by A star formula. 2 upon gamma plus 1, 1 plus gamma minus 1 by 2, m exit gamma plus 1 divided by, you calculate this a exit by this formula. If you calculate, check. So here it is nothing but 1.91 I can say. This is what A by A star approximate value. If you go accurately 2 digit, then maybe data a little bit change, but yes, 1.91 I'm writing here. Okay. Once you got A by A star, here in the problem itself they are asking both exit area as well as throat area, both they are asking exit area and throat area. So this ratio, whatever you achieved here, A by A star, that is okay. Okay, this is useful, but the thing is they are asking, they, both are unknown, AE and A star both are unknown. So anyhow, if you one data you know, then the other area you can calculate. I mean, if you know throat area, then you can calculate exit area. If you know exit area, then you can calculate throat area. So check any other data they have given to you. So one thing is very nicely they have given, they had said nozzle thrust they have given to you, thrust. So obviously thrust, I cannot say it is T because it is the thrust, otherwise T means exit temperature. The thrust they have given to you, which is nothing but 11.12. So this data they have given 11.12, you can say thrust. How much? 11.12 kilo. We will use this, yes or no? I had told you that what it is called, the how to calculate the exit velocity, yes or no? So if you know what is the exit velocity, then thrust area will, I mean thrust will be easy to you to calculate the value. So what is the exit velocity? Exit velocity from CD nozzle. So here I had given the formula, and that formula was because if you want to use this the thrust, so for that reason you can because if you write the thrust formula for the CD nozzle, then I will tell you pressure will also come, but in that if you go, then pressure will be cancelled out. Why? Because it is fully expanded, no? So exit pressure and atmospheric pressure will be same, so that value will be cancelled out. So that is the one way to calculate uh, exit area. Otherwise, one more thing you can, if you think about it, then you will understand. I have given here this throat is what choked, and throat is what choked, then mass flow rate will be maximum. That is also correct. So maximum mass flow rate from the CT nozzle or reservoir we had seen. Okay, so if you use that formula, then also throat area you can get. Once you get throat area, you can get exit area. Otherwise, you calculate exit area, then you calculate throat area, because ratio you have, see. So both way we can go. Okay, both way we can go. Check this exit area and throat area ratio we have. So one we have, we can calculate exit area. Another what we have, we can calculate throat area. So both I think we should do. Okay, and we'll check the result. So exit velocity from a CD nozzle. So how to get it? So it is nothing but VE is equal to, what is the formula? 2 CP P naught minus T exit. Yes, this is the formula now. Yes or no? This is the formula now in root. Okay. And once you get the V exit, we can write thrust formula from the nozzle, that I will write. So now we have that ratio. Okay, what is the ratio we have here? That formula of T naught by Te is equal to 1 plus gamma minus 1 by 2 me square. T naught we have, what is the T naught check? T naught is 353, and what is the me? 2.15. So 353 divided by Te 1 plus gamma minus 1 by 2, me is 2.15. If you solve T exit, you may get it. It's a 183.4, near about, no? If little bit variation also possible, but approximate this value you may get, because it is expanded. Okay, all right, now check. So T naught we have, and Cp, because gamma air you have taken, you are taking gamma is 1.4, and Cp also you can say it is air. So that time I told you 1005 joule per kg Kelvin, or also I had said 1.005 kilojoule per kg Kelvin. This is the data, no? You can calculate exit velocity. 2 Cp T naught you have minus Te. If you do this, you will get Ve 583, or I can say 584 meter per second. Okay, this is the exit velocity. Now you are going to write the thrust. So thrust equation, yet I have not derived the thrust equation for the CD nozzle. I will derive it in jet propulsion topic, but I can in short I can give the formula. Okay, so this is the CD nozzle, it is given. Now check there. So this is the back pressure, which is the, and here it is exit pressure. Okay, PB it is given 1 atm. All right, AE exit area, and we can say the mass flow rate, it is nothing but m dot. What is the mass flow rate? Rho. Okay, E area E, V exit E, rho AV. All right, now if I will write the thrust equation, in short I am writing, I am believing that you know already this formula. Okay, but this formula will be derived in jet propulsion subject. So thrust will be m dot mass flow rate into basically velocity. Okay, plus exit pressure minus back pressure or atmospheric pressure. I can write exit minus atmospheric pressure, here it is given back pressure, into exit area. This is the formula. So here they have given, what they have given, PE is equal to PB, they have given to us, because it's a fully expanded case. I can say this part will be 0. So what is the thrust? M dot VE, yes or no? And in m dot, what they have given to us, mass flow rate rho E, AE VE into VE. Yes or no? Now I can say thrust, which is nothing but rho E AE VE square. What is the rho E? It is PE by RPE, exit area, velocity square and thrust. Okay. What will be the area A exit? Thrust they have given to us how much? I think 11.12 kilonewton. 11.12 kilonewton. So 11.12 kilonewton 10 power 3 divided by, what is the PE they have given? I mean, you have calculated something, I think. You have not calculated. PE is PB, no? 1 atm. 1 atm they have given already. Take it. 1 atm. 1 atmospheric pressure means 101.325. Okay. Divided by R for air is nothing but 287. Already I have told you in my previous lectures. TE temperature, exit temperature you had calculated, it was TE, it was 183.4. Okay. And VE, what is the velocity VE you have calculated? VE 584. We'll find this. So here you got 0.0169 meter square, or you can write 169 centimeter square. Okay. Once you got exit area, then throat area you can calculate. How? They have given AE by A star 1.91. AE by A star 1.91. So exit area you got. What is the A star? It is throat area, and throat area is nothing but A by 1.91. What is the exit area you got? 169 centimeter square. 1.91. If you do this, my calculator, 169 divided by 1.921, how much? It's 88.48. So you got A star, which is nothing but throat area, 88.48. Okay. This is your answer. So this is your answer. But I will tell you, I told earlier also, there are two ways to solve this question. Okay. How? Because one very good application, and that I also want to show you. What is the good application here? The Mach number in the divergent section is 2.15. That means it is m greater than 1. That means because exit is Mach number Mach greater than 1, supersonic, it means in convergent it was subsonic. It means at the throat it was m is equal to 1. When m is equal to 1, then there it is called choked flow, and that choked flow, at the time of choked flow, mass flow rate you will have maximum. This concept you use and cross check your answer. Okay, it will take hardly 5 minutes, but you will be the happiest person once you cross check the answer and if you are getting the same. That usually always happens. Okay, so we'll do here what we say. As we know, the flow is choked. Why? Because you are at the throat, you are getting m star is equal to 1, and when you are getting m star 1, it is called choked flow, and that time you will get maximum mass flow rate. So and we know that maximum mass flow rate formulation already we had seen. Maximum mass flow rate I had given that time. What was the formula? 0.6847 divided by this formula already given to you previously. To go and check your notes, it is given. I had derived this maximum mass flow rate P naught, and it was ATH throat area. So we'll use this. Okay, and we'll get the throat area here. How you will do it? It's very simple. Now I will go fast little bit because already answer you got. Now we are cross verifying. So first you will calculate the mass flow rate. How you can get this? Because the nozzle is what fully expanded. So for fully expanded nozzle, fully expanded nozzle, for fully expanded nozzle, for fully expanded nozzle, that thrust will be what? I told you that mass flow rate into exit area, and that pressure term will not be here because it is fully expanded, so this value will be 0. Always remember. So whatever the mass flow rate you will get, it will be the maximum will be thrust by velocity. You already have seen thrust is 11.12 kilonewton 10 power 3 divided by exit velocity. Also you have calculated. It was I think 583 somewhere you have calculated here. 584. 584. If you check this, let me calculate. 11.12 power 10 power 3 divided by 584. Here it is 19.04 kg per second. This is the mass flow rate. And remember, because the nozzle is what choked, so this is the maximum mass flow rate. We have maximum mass flow rate formula M max. What is that? It is 0.6847 divided by root of RT naught throat area into P naught. So we'll get, because this maximum mass flow rate just now you have calculated how much. It is 19.04. Okay, we'll get this ATH. ATH is nothing but 19.04 into R. 287 into what was the T naught? It was 353 if you check, and the rest will be in denominator. So 0.6847 into P naught. P naught was 10 bar if you remember. 10 bar. Okay, so 10 into bar, 1 bar means 101.325. If you calculate this ATH, so let me check how much it is. 287 into 353, take root of it, multiplied by 19.04 divided by 0.6847 into 10 into 101.325. put in box. We are getting 8.735 into 10 power minus 3 meter square, or if you convert in centimeter square, so just multiply it by 10 to the power 4. So how much you may get? 87.35 centimeters. Okay. 8 years by, check what is the A star by, what is the ratio? AE by A star. AE by A star. A star means throat. AE by A star. What is the value you are getting? AE by 1.91. Yes or no? If you do this, so this AE, A star means throat. So what is the AE? It is throat into 1.91. How much? You are getting 87.35. 1.91. What is exit area? 10 to the power 4 multiplied by 1.91. It's 1.91. What value I am getting? 87.35 into 1.91. It's a 166. 166.83 centimeters. Just cross check your answer. This is the exit area, okay, and this is the throat area by the another method. This is the second method you have used. Now check your previous method. A star throat area you got 88.48. Here you are getting throat area 87.35, which is very close. Doesn't matter. Exit area you got 169 centimeter square. By another method you got 166.83. It is also very close, you can say. It is almost close, so you can accept this. Or maybe sometimes if you have not fixed your calci up to 2 digit, so because of that also sometimes there is the mismatch, little bit mismatch, not more than 5%, but yes, it is very close, you can accept it. All right. This is problem number 2. A rocket nozzle has an exit throat ratio, exit throat area ratio, of 3. Okay. The combustion the combustion the combustion gas mixture at 20 bar and 2500 Kelvin is expanded through the nozzle. Expanded through the nozzle to an atmosphere at 1 bar. The molar mass of the gas mixture gas mixture is 30.5 kg per Kelvin and gamma is 1.2, assuming the flow process to be isentropic. Okay, process to be isentropic. Estimate thrust generated by the nozzle, per unit area. Okay, now if you check, mark all the given data. The exit throat area they have given how much, 3. Combustion gas mixture they have given 20 bar. Okay, temperature they have given 2500 Kelvin is expanded through the nozzle to an atmosphere, and that atmospheric pressure also they have given 1 bar. The molar mass of the gas mixture they have given, so we find the characteristics gas constant, gamma value they have given to us. Throughout the nozzle, that flow is what, isentropic, so it means there is no shock formation. Okay, no shock no shock formation. All right, fine. We'll see this is the rocket nozzle. So we can have this rocket nozzle, it's a simple only. Now we can say okay, this is what rocket nozzle. All right, and this is basically rocket. Okay, you say this is what combustion chamber here. These are the propellant. Okay, and that hot gases are coming outside like this. Okay, so here whatever the in combustion chamber, whatever the pressure and temperature, it will be a total pressure and total temperature. Okay, always remember P naught and T naught, always remember. Yes, so they have in the problem it is given that P naught is how much, it is 20 bar, and T naught and P naught in the sense total pressure and total temperature. What is the total temperature? It is T naught, which is 2500 Kelvin. 2500 Kelvin. This is the total temperature. Okay, now we'll solve this. So check, first of all, see this, they have given the gas mixture, that molar mass they have given and gamma value they have given. So with the help of this molar mass we can find the characteristics gas constant. What is the characteristics gas constant? Universal gas constant divided by molar mass. So it is nothing but 8314 divided by 33.5. If you do this, then how much you may get? 248 joule per kg Kelvin. This will be the value of R. Okay. What they are asking here, check in the problem, they are saying calculate or estimate the thrust generated by the nozzle. So what is the thrust equation? What is the thrust equation? Thrust T is equal to, okay, thrust T is equal to, it is nothing but mass flow rate into exit velocity VE, okay, plus exit pressure minus atmospheric pressure into exit area. This is the thrust formula. If you check here now, what is the exit velocity? This is what exit velocity here, okay, this is the atmospheric pressure, you can say PA here, this is the exit pressure PE here, okay. All right, now they had said expanded through the nozzle to an atmosphere at 1 bar. So they have clearly mentioned it is expanded to the atmosphere. I mean, there is no under expansion, there is no over expansion case. It is exactly expanded to the atmosphere. If it is exactly expanded to the atmosphere, then what will be the thrust will be 0, because it is now the case of fully expanded, okay. It is called fully expanded case. If it is fully expanded case, then PE is equal to PA. So this part will be what? 0. Okay. Then what will be the thrust? If you find here, what will be the thrust? Thrust will be P is equal to, it will be m dot into VE. Okay. Fine. So how to get this VE? This is the question. How to calculate this mass flow rate into V. This value, if you know, then thrust you can calculate. In the problem, what they had asked, thrust per unit area. If you check this value, what they are saying, thrust generated per unit area of the nozzle. So in the problem, they are asking thrust generated divided by area of the nozzle. Area of the nozzle means it is nothing but ATH, thrust generated by the nozzle per unit area. Even though you can calculate thrust per unit area, anyhow if possible you can calculate thrust per unit exit area also, but here they have said thrust per unit area, okay. So if they are saying thrust per unit area of the nozzle, so I am considering that area is what? Throat area. So where is the throat area in the problem? See, this is the throat area here. This area is nothing but throat area, okay. This is what? Throat area. All right. Now this is very interesting question actually. So what will be the thrust per unit area? It will be the m dot divided by ATH into VE. Now this value you need to calculate, okay. How to proceed it? It's very simple. How to get that throat area and all. So first of all, you need to check if it is possible. You need to check that flow is what choked or not. If it is choked, then maximum mass flow rate you can calculate, and in maximum mass flow rate, throat area is there, so easily you can get m dot by ATH. Okay. Before that, you have to think about the VE. Okay, what is the VE? And this VE is nothing but exit velocity. And how to get it? It's very simple. That exit velocity, you can say, last class also we had seen one numerical and we had calculated the exit velocity or jet velocity from the CD nozzle. So if you check the formulation, so formulation is what? VE is nothing but 2CP. This was derived formula. Last class I had derived T naught minus TE in rho. This is what exit velocity. Okay. Also, you can say exit velocity is nothing but exit Mach number into speed of sound, and speed of sound at what it is, speed of sound at the exit, because you are finding exit velocity, so gamma RT. I mean both formula are correct, any one you can use and you can calculate the value. Okay, so what is the exit velocity? Exit velocity is nothing but ME root of gamma RT. This formula also you can use, it's your choice. Okay, now the thing is how to get the exit Mach number. Okay, so for that reason, why I am using this formula, it's very simple, because here they have given area ratio. Check what they have given, exit to throat area they have given to us, means exit to throat area means AE divided by ATH. They have given how much? 3. Okay, so I had given one relation last class and it was derived also, and that relation called area Mach relation. So now you can use the area Mach relation. What is the area Mach relation? Area Mach relation is nothing but AE by ATH 1 upon ME in bracket 2 upon gamma plus 1, okay, in bracket 1 plus gamma minus 1 by 2 ME square, okay, the whole power gamma plus 1 divided by 2 gamma minus 1. Now if you solve this value, what they have given, this ratio they have given 3, so 3 is equal to 1 upon ME 2 upon gamma plus 1, okay, 1 plus gamma minus 1 by 2 ME square gamma plus 1 divided by 2 gamma minus 1. If you solve this equation by hit and trial method, okay, you can write solving this by try and error, then, or you do one thing, you directly you can write this equation in calculator and shift solve. One option is there in your calculator, shift solve. If this type equation you can write in your that calculator, engineering calculator, okay, and one option is there, shift solve. So if you write this equation properly, okay, or the left and right side value make equal sign and then shift solve, then one approximate any value they will ask to you. So as per the record of area ratio A by ATH, two different value of the Mach number you will get. One will be subsonic, another will be supersonic. So if now here this, write this equation in your calculator and shift solve, then they will expected value of ME they will ask. So you can give any number greater than 1, means supersonic zone you want to check. If you do that, then and calculate this, so ME you will get here. Now you can do it. So if you write this equation, let me check in my calculator. So this is nothing but 3 is equal to 1 upon ME in bracket 2 upon gamma plus 1 bracket 1 plus gamma minus 1 by 2 ME square whole power gamma plus 1 divided by 2 gamma minus 1. Okay, shift solve. So shift solve ME I am giving and one expected value, it is greater than 1, so I'm 2 I am giving here. Okay, so okay, equate this. Then here I am getting ME, which is nothing but 2.4 approximate. So this is the value of ME. You can solve in your calculator also, shift solve method. No? So this is the Mach number at the exit now you have. Exit Mach number you have now. Alright. This is the value, exit Mach number. Now as I told you, you can write the value of exit velocity. So what is the exit velocity? Two formula I have given to you. One, you can use 2 cp t naught minus t, okay, or is equal to you can write me root of gamma rp. This is also one formula. How to use this formula? Very simple. T naught minus T. So one formula you have T naught, because the flow is what isentropic, so this isentropic relation you can use. It is nothing but 1 plus gamma minus 1 by 2 m square, and T naught is given how much? 2500 Kelvin. I think check 2500 Kelvin. It is given 2500 Kelvin by Te is equal to 1 plus gamma, I think 1.2 here it is given in the problem itself. What is the gamma value? It is 1.2. Check. So we can write 1.2 minus 1. Just now you have calculated ME 2.4 square. So what is the TE? Let me check in my calculator. I'm getting here 2501.57. To solve this, you will get 1586.3 Kelvin. This is the value of TE. Okay, 1586.3 Kelvin. Check this value, cross check. So this is the value of TE. It is nothing but exit temperature. You can use this value in this formula, so you will get ME. What VE? What is the VE? ME root of gamma TE. This value you can, all the value you have 2.4 Mach number, gamma is 1.2, R you had calculated in starting only. What was the R? It is 248, and just now you have calculated here 1586.3. 1586.3. Calculate it. Let me check this value, how much it is. I'm getting here 1649 meter per second. What is the VE? It is 1649 meter per second. All right. This is the exit velocity. Now you need to calculate the thrust per unit area. What is the formula I have given to you? Thrust per unit area is nothing but this is the thrust per unit area. This is mass flow rate divided by area into VE. So VE you have now mass flow rate by area. We need to find. How we can find? It's very uh, like derived formula we have here. What is the derived formula? You can say check. uh, because here the exit Mach number is 2.4. You can write here exit Mach number is 2.4, means ME is 2.4, which is greater than 1, means 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 the flow is choked at the throat of nozzle, is or no, at the throat of nozzle. So one way you can write the maximum mass flow rate, because now it is choked, and choked flow always give the maximum mass flow rate. That concept you can apply if you want here. Otherwise separately also you can write the mass flow rate formula. But here this is very clear now that mass flow rate what we have, it is maximum because nozzle is what choked. So this maximum mass flow rate is nothing but 0.6847 divided by RT naught T naught into 8 years. This is the formula, already I have derived this in class. Check previous lecture, so you will get this formula. Okay, this is already derived. So here what is the mass flow rate for unit area? If you check, it is nothing but mass flow rate. This is nothing but maximum mass flow rate divided by 8Th. So this is nothing but 0.6847 root of RT naught into T naught. All the volume we need to write 0.6847. What is the P naught? In starting only it was given, I think it was 10 bar. No? Check in the problem. Check the P naught was 20 bar. Sorry, 20 bar. So we need to write here 20 bar. P naught is nothing but 20 bar 10132 by 1 bar is equal to, and R was 248 and T naught was 2500. We'll calculate this and then we'll cross check. There is another method also, you can do this problem. Okay, but I am doing by this way. 0.6847 into 20 into 101,325, okay, divided by, in the root value we have 248 into 2500. This is nothing but 1762.1833. I am getting here 1762 not. To solve this, then okay, 0.6487 258 into, once again I need to do T naught is this value, take the root of it. So 787, here in bracket I need to write 0.6847 into 20 into 10 power 5 you write, and this value 1739, little bit different value I'm getting, but it's okay. So here I'm getting m dot divided by 8th 1762.1. This is the value of mass flow rate per unit area. Now they are asking in this problem, they are asking thrust per unit area, right? Thrust per unit area. So I have told you thrust per unit area is nothing but mass flow rate per unit area into exit velocity. It is mass flow rate. You can write here what is the thrust per unit area, which is nothing but T divided by A. So it is nothing but mass flow rate by area into VA. Now if you solve, this is nothing but 1762.18, and what is the VE you had calculated here? It is 1649. It is 1649. So it is 2 meganewton. This is the value, but in book I am getting different, little bit different. It's a 2.7, but this is the huge amount. I don't know. Okay, let me check here. Oh, okay. See, if you remember this value when I derived, this is for this constant 0.6487. If you remember, this was for gamma air, and that time gamma air was 1.4. Here gamma they have given 1.2. Because of it only I did mistake. Yes, gamma they have given. Okay, please correct it. Gamma 1.2. So now this formula you will not use. Hope you understood the mistake. Here everywhere it is correct. Only this formula you will not use. This constant value you will not use. Okay, will not work. That time in exam also you need to remember. Okay, so I must say whatever here you have taken the value here, it is not correct. Now do one thing. I will write the main equation, and by that equation only you can proceed. Okay, let me correct this. Let me correct. This formula you will not you will not use. In the same, if you remember that equation, and there gamma was there, if you remember, and that gamma you can write not because it's not here, it's a gas in the rocket nozzle, so gamma is 1.2 given, so you cannot use this. So even here whatever I have calculated, this is not correct. Hope you understood that mistake, right? Fine. So how to get the result directly? So in examination what to do? I mean, if you don't remember the value, then what you will do? So it's very simple. If you remember the mass flow rate in terms of Mach number, or one more formula was there, that was the mass flow rate, non-dimensional mass flow rate. If you remember, non-dimensional mass flow rate. So that non-dimensional mass flow rate, if you write, okay, that was given in terms of gamma, and that was that value was also it was what that maximum mass flow rate also there you can write. So that result you can write, otherwise need to derive this. So for this reason I am saying this formula will not be used, because this formula, I mean 0.6487, this constant was for gamma air is equal to 1.4, but in the problem they have given gamma is equal to 1.2, so this formula will not work. So we made mistake, now we'll correct it. So we can write mass flow rate in terms of Mach number and gamma. Okay, so we had seen that mass flow rate in terms of Mach number, and what was the formula? M dot divided by, we are taking throat area ATH, is equal to P naught. If you remember, M in root, this was derived in class only. If you check your notes, you may get gamma T naught divided by 1 plus gamma minus 1 by 2 m square. This was gamma plus 1 divided by 2 gamma minus 1. Yes or no? Check, this was the formula, and this is the mass flow rate in terms of Mach number. We are finding m dot by ATH. So what is the Mach number at the throat? Because exit Mach number is what, 2.4 here, what we have calculated, no? 2.4. Check, so 2.4, right? So obviously if exit Mach number we are getting 2.4, it means at the throat it reached sonic flow, no? It means at the throat, you can write at the throat m will be 1, then only it will be choked flow, right? Then in only it will be choked flow. Yes or no? So you can write in the formula, you can write m is equal to 1. So for m is equal to 1 at the throat, we can write here at the throat. That's also, when I had given this formula, I said this is very important, very master formula actually. Many times it happened, they will give the Mach number, so that time this formula, if you know, if for any Mach number you can calculate this mass flow rate, okay, for any Mach number. So because I am going to calculate at the throat, so throat Mach number will be 1, so I can keep here 1, no? So it is nothing but m divided by ATH, and what is the formula? P naught m. So I can write P naught m is what, 1 in root, it is nothing but gamma upon r P naught divided by 1 plus gamma minus 1, 1 plus gamma minus 1 by 2, 1 Mach number is 1, m square to whole power, it is nothing but gamma plus 1 divided by 2 gamma minus 1. Yes or no? Now you can check, this is nothing but P naught in a root gamma upon RT naught divided by, if you solve this bracket, because 1 square means 1 plus gamma minus 1 by 2, if you solve this will be gamma plus 1 by 2 to whole power gamma plus 1 divided by 2 gamma minus 1. Now you keep gamma value, all the value you have now, you can get this. Please perform the calculation. If you do this, then you will have m dot by ATH is equal to P naught is 20 bar, 20 into 101,325 in a root. What is the gamma? It is 1.2 divided by r is nothing but 248. What is the T naught? It is 2500 Kelvin divided by gamma plus 1 means 1.2 plus 1 divided by 2 to whole power gamma plus 1, 1.2 plus 1 divided by 2, 1.2 minus 1. Okay, this is the value, right? Now if you solve, check what value you are getting. After solving this, the approximate value will be, you can say here 1669 almost, no? 0.5. This is the approximate value. Okay, now you got m by ATH. What is the thrust? per unit area, it is nothing but T divided by ATH. I had given previously, it is nothing but C. It is nothing but the other formula I showed you. Check here the thrust per unit area will be mass flow rate per unit area into exit velocity, right? So if you use this formula, then exit velocity already you have calculated. What is the exit velocity you had calculated here? It was 1649. Okay, it is mass flow rate by area into V exit. So this value you have calculated 1669, 1669.5, 1649 is the exit velocity. T by 88. So approximate you will get 2.745 mega Newton. This is the answer. This is answer for this problem. Okay. So similarly, many problems we have. Okay, many problems we have, but we cannot solve here all the problems. Okay. So now hope this problem is clear to all, and what mistake we had seen already. This again I will suggest, blindly don't use this formula, okay, because this constant is what for gamma is equal to 1.4. so if they have given air, then obviously you can use this formula for the mass flow rate, but if gamma they have changed, then don't use. Better you remember this formula. This formula is what mass flow rate in terms of Mach number. It is derived in my previous lecture. Now because at the throat flow is what choked, in the sense, because exit Mach number we are getting 2.4, which is greater than 1. It means Mach is what 1 at the throat only. So at, because you are writing mass flow rate by area, so this area is what throat area, hence this Mach number will be the throat Mach number, and this Mach number will be 1 because flow becomes choked condition at the throat. So if you keep here m is equal to 1, then the next solution you already have seen. All right.